Now, question number 4 is completely based on the formation properties of a triangle. So, basically, two very important properties of triangles will be applicable here. The first property will be the sum of any two sides of a triangle should be greater than the third side. All right, it cannot be even equal. So, the sum of any two sides should be greater than the third side. This is the first property. The second property that will be used can be uh, every side of a triangle should be less than half the perimeter. Okay, so the side can also not be equal to half the perimeter. It has to be less than half the perimeter. Now, using the second property, I can say that every side will be less than 18 upon 2. That means every side will be less than 9. Okay, so every side, if it is less than 9, so I can say that the maximum possible value, the maximum possible length of any side, because all the sides are integers, the maximum possible length will be equal to 8. So the length of any side of this triangle cannot exceed 8. Done? Okay. Also using this property, now let us start forming these different triangles. Okay. So I'll go in a proper direction. So first of all, I'll assume that the minimum side can be 1, then minimum side 2, minimum side 3, and so on. And I'll keep on making the triangles. So I can say that maximum length can be equal to 8. Okay. So if the minimum length of the side is 1, then out of 18 parameter, I'm left with 17. Okay, 17 is left. Now, if 17 is divided as close as possible, I can get 8 and 9. Now, 8 and 9, first of all, it is not satisfying this property where it says that the maximum length will be 8. Okay. Also, it is not satisfying that the sum of any two sides will be greater than the third side. So now, any two sides whose sum is 17, if I'll write 17 as the sum of any two numbers, one of the numbers will be either 9 or greater than 9. So I can say that triangle with side 1 is not possible. Okay, so with the minimum side length 1, the triangle is not possible. Now I'll try for 2. So if minimum side is 2, then the sum of the other two sides, remaining two sides, will be equal to 16. 16, first of all, it can be divided equally as 8 and 8, which is satisfying both the properties. Okay, if I try to make some other triangles by reducing one of the sides by 1, 7, and increasing the other side by 1, 9. So maximum side should be 8, so I can say that this will not satisfy. So only one triangle is possible with side 2. Now the third case, the side has 3. So remaining is 15, the sum of the other two sides. 15, if I divide it in two numbers which are as close as possible, so it will be 7 and 8. Okay, so 3, 7, and 8 is one of the triangles. Yes, it is satisfying the other properties. If I reduce 7 and increase 8, okay, then 8 will become 9, and I cannot go beyond 8. So that means with the side 3, only one triangle is possible. Now side 4, remaining 14, the sum of the other two sides. I'll write 14 as 7 plus 7. This is possible. Then reduce 1, 6, and increase 1, 8. So 4, 6, 8, yes, it is also a possible triangle. But now I cannot reduce 6 further to 5, otherwise I'll have to increase 8. So I'll stop here. So this is the two possible triangles. These are the two possible triangles with minimum side as 4. Next, minimum side as 5. So if one of the side is 5, the sum of the remaining two sides will be equal to 13. I can write 13 as 6 plus 7. Okay, I can reduce 6, so it can become 5, and increase 7, it can become 8. So 5, 5, 8 can be another possibilities. So I cannot reduce 5 further to 4. Otherwise, one thing is minimum side I have assumed as 5. So I cannot go below 5. Next, with the side 6. So I have 12 as the sum remaining. The other two sides can be 6 and 6. So if 6 is the minimum side, I cannot reduce or I cannot reduce any other side further. So this is another possibility. Now after this, if I'll assume minimum side as 7, so minimum perimeter required is 21, but the perimeter is 18. So I'll stop here. These are all the cases. Now you can count all these cases: 1, 2, 3, 4, 5, 6, 7. So if you'll follow this proper direction, then you will not miss any case and you will not have duplications or triplications of cases. So the number of triangles which are possible is equal to 7.